Let's look at some questions to review Chapter 2. The first one has two tables that represent responses to a survey about legalizing the concealed carry of firearms on college campuses. The respondents were split into two groups, non-students and students, and these tables represent their responses to the question whether they support this type of legislation. The first thing we're going to do is create relative frequency tables for both of these. To do relative frequencies, we want to take the frequency in each category and divide by the total for that table. For this first one, we would take 12 divided by 141. This tells us to round to 3 decimal places. That's going to give us 0.085. For this one, we would take 101 divided by 141. That gives us approximately 0.716. For this one, we would divide 28 by 141 and get 0.1199. If we want to check our answers to these, we can add the 3 together, and they should come out either to be exactly 1 or to be very close to 1. In this case, if you add these 3 numbers, you do get exactly 1. So this is just a way to check your answers. We can do the same thing for this one. This has a different total, so this time we're going to divide by 252 for each one. If we divide 155 by 252, we get 0.615, and if we divide 83 by 252, we get 0.329. Again, we can check by adding these 3 together. This time they turn out to be exactly 1. The next question is why relative frequencies would be more useful than the actual frequencies for these two sets of data. That's because our totals are different. And that means that if we're looking at the actual frequencies, it's hard to compare between these numbers and these numbers. There are so many more in this group than there were in this group. So this is because the total frequencies are different. We have 141 for the first group versus 252 for the second group. The next question is which of the following types of graphs would be more appropriate for displaying this data? If we look at the survey responses, this is categorical data because the survey responses were words. So anything that's appropriate for categorical data would be good for this data. That would include bar graphs, pie charts, Pareto charts, which are just another form of a bar graph. The one that wouldn't be appropriate would be a histogram, because this is for quantitative data only. That would not be appropriate for categorical data. For number 8, we have another frequency distribution for the number of hours worked per week by some statistics students. First, we're going to think about the shape of this distribution, whether it would be bell-shaped, skewed left, or skewed right. If we look at the numbers, it's a little bit hard to tell looking at the table. If you think about what a histogram for this would look like, these numbers would be on the left. So this would be at the left end of the graph. This would be at the right end of the graph. So if we even thought about a little histogram for this, we've got a pretty low number here on the left end of 16. Then our numbers start going up. I'm not really trying to be super accurate with this. I'm just trying to get a picture of what's happening with the graph. So our graph would look roughly something like this. We've got more data on the right side, and the left end has a longer tail. That means that this would be skewed left. This is the one that's kind of confusing because it seems like to be skewed left, it should have most of the data on the left side, but it's exactly the opposite of that. What you want to look for is where the tail is longer, and that's the direction of the skew. Thinking about which type of graph would be appropriate for this data, because the number of hours is quantitative, that means that a histogram would be appropriate in this case. It would be more appropriate than a Pareto chart or a bar graph. Now let's look at a display that is misleading. For this one, a television manufacturer sold 3 times as many televisions in 2005 as it did in 1995. The manufacturer created the graph that we see here. The TV on the right is 3 times as tall and 3 times as wide as the TV on the left. So the question is, how is this misleading? It's misleading because they used two dimensions to represent this, so it really exaggerates how much bigger this is than this one. It's misleading because they use two dimensions. If they wanted to create a display that was not misleading, they could have just done a bar graph. They could have had the 1995 as one bar, and then for the 2005, they could have had a bar with the same width, just 3 times as tall. So something like this would not be nearly as misleading as this one. Here's another graph. This one is used in an ad for Paulo's Salsa. This is representing the results of a taste test. The question is whether this graph is misleading or not. This one's a little bit harder to see, but if you look at the horizontal axis, the number here is not 0, it's 40%. So yes, this is misleading because it has a non-zero axis. What that is going to do is exaggerate the difference between this level and this level. If we really look at what these two levels are, this one looks like it's about 42%. This one looks like it's something like 58%. So really there's not nearly as much difference between those two as this graph seems to show. Now let's look at a histogram. In this histogram, first we're going to find the class with the highest frequency. That means we're looking for the highest bar, but to say what class it is, we want to look at the x-axis and see what our values are. Here's our highest bar right here. So where that is on the x-axis, it looks like that's starting at 250,000 and it's going up to 300,000. We have to go just a little bit under the 300,000 though. This would be 250,000 up to 999,000. The class with the lowest frequency, that would be this one over here. To say what class this is, it starts at 500,000, and then following what the rest of these did, this would go up to 549,999,000. If we're looking at the class width, that's just the width of each bar. For example, this one went from 250 up to 300,000. If we looked at the limits of those two classes, the difference between those two is 50,000. Now we want to find the approximate percentage of homes with selling prices between 300,000 and 399,000. So that's from here all the way to here. We're going to take these two bars. We want to figure out the percentage for each one and then add those together. This one looks like it's 25%. This one looks like it's approximately 16%. If we add those two together, we would get 41%. Then the last question is to find the minimum and maximum data values. In this one, because it's a histogram, this isn't actually possible to exactly specify what those values are. We can estimate because our lowest class limit is 200,000 and our highest is 550,000, but those would just be estimates. We don't know exactly what these data values are. For the next problem, we're looking at a stem and leaf plot. This shows salary data for clerical employees at a company. If we look at the stem and leaf plot, it tells us here that the stem width is 10,000. That means that the stems over here represent 10,000. That means that the leaves over here would represent 1,000. So these are 10,000s. Each one of these represents 1,000. The highest salary value that's shown would be the last value here. So our stem over here would be 40,000 and this leaf would be 6,000. So that would be 46,000. The highest salary value that's shown would be 46,000. Then we want to find which stem has the highest frequency. We're looking for which one of these goes the furthest out to the right. That would be this one. Notice in this stem and leaf plot we have split stems. So this stem goes from 20,000 up to 24,999 because the next stem starts at 25,000. So this is our highest frequency one. And then we're also looking at the shape of the distribution. When you have a stem and leaf plot, this is just like a histogram that's turned on its side. So one of the easiest things to do is just take this and turn it like this so that you have your smaller numbers to the left and the bigger numbers to the right, and then look at what the distribution shape is. In this case, our data values are mostly on the left side of the graph, and we've got a longer tail on the right end. That would mean that this is skewed to the right.